A very good morning to all the students. I am Dr. HIma Bindu from the Department of Mechanical Engineering in Institute of Aeronautical Engineering, and I'll be dealing with the subject robotics, and my today's topic is definition and terminology in trajectory planning, which comes under module 4. So coming to the first definition and terminology, what is a trajectory planning? Most of them are not aware about what is a trajectory planning or what is the difference between a trajectory planning or a path planning. So here, in this particular definition, let us first know briefly about what is trajectory planning and why it is used and where it is used. Right? Generally, this particular trajectory planning is referred to as a motion planning, or we also can call it as a erosionous path planning. Right? That is, a trajectory planning is something which is moving from one position to the other position while avoiding collision over time. For example, we are at a point A and this is a point B where the robot has to move from point A to point B, and in between you have few collisions being placed, right? So the trajectory plan is something where the robot is being moving by reducing all these particular collisions and reaching to the final destination, that is moving from point A to point B while avoiding collisions over a period of time. Right? Now this can be computed in both discrete and a continuous method. That is, this can be a continuous method. Right? This can be a continuous method. The trajectory planning is nothing but a major area in the robotics as it gives way to autonomous vehicle. Right? And as I've told you, the trajectory planning sometimes is referred to as motion planning, right? And erroneously as path planning. Right? It is any particular robot when it has to move from one initial position to the final initial position by avoiding all the obstacles, the planning has to be done before. Right? That is known as the trajectory planning. Next, moving on to the next concept, what are geometric constraints? What do we mean by geometric constraints? Geometric constraints is nothing but the expression in terms of the robot joint angles that include the joint angles, bounds on the joint angles, and avoidance of the self-collision with the obstacles. Right? The geometric constraints are nothing but they are expressed in terms of the robot joint angles, where they include the bonds of the joint angles which avoid the self-collision and the collision with the obstacles. These constraints can thus be fully taken into account in the path planning step. That is known as the geometric constraints. Next, what is the role of optimization? Optimization means what? Optimization means finding the shortest, best possible way. Right? Yes or no? Optimization means finding the best shortest possible way. So when the robot has to move from one place to the other place, it has to optimize its particular path. That is, it place where there are more than one path. That is, when there are more than one paths, right? When a robot is having more than point, for example, path A and path B, right? It can move in this particular direction. It can directly move in this particular direction, or it can move in this particular direction. In any of the direction. This is 1, this is 2, and this is 3. So the robot has to select the shortest possible path where it can reduce the time constraint, right? And the work, whatever it is doing, can be completed within the time. right? So optimization is one of the important concept which plays a very important role in the trajectory planning, right? Where it is used to select the path or the trajectory that optimizes a given objective. That is known as the optimization. What is joint space trajectory? The next concept is what is joint space trajectory. Generally, this particular type of the trajectory is a common usage in robots to provide a smooth, continuous motion from one set of the joint angles to another. Right? In order to have a smooth and a continuous movement, right? In order to have a smooth and a continuous motion of the robot joints to be taken place within its particular instance for moving between two distinct Cartesian poses is known as the joint space trajectory. That is, a joint space trajectory is a generation in common usage in robots to provide smooth, continuous motion from one set of the joint angles to another for moving between two distinct Cartesian poses for which the inverse pose solution has yielded two distinct sets of the end joints. That is, any particular robot when it should have a continuous motion of the joint angles or when it should have a smooth motion of the joint angles, this particular joint space trajectory comes into action. Next, what is the role of obstacle avoidance? Right? What do we mean by obstacle avoidance? That is when any robot is moving in any of the industrial area or in any of the organization, we have to give the programming to that particular robot in such a way that it can identify at what place the obstacle as is present, and that particular robot with its particular senses will be acting accordingly by avoiding the obstacles. That is, the way to address the motion problem is known as the obstacle avoidance. That is, the way to address the motion problem is called as the obstacle avoidance. The main objective is to move a vehicle towards a target location which is free of collision with the obstacles detected by the sensors during motion action. That is, when the robot is moving, it should detect with the help of the sensor, it should detect where the obstacle is and it should avoid that particular obstacle or the collision and reach the destination point. Right? That is known as the obstacle avoidance. Next, what is the advantage of reactive obstacle avoidance? Right, in obstacle avoidance, we have one of the other portion called as the reactive obstacle avoidance. What is the advantage of that? Generally, this particular reactive obstacle avoidance is a compute motion which has been introduced by the sensors information within the control loop, where it is used to adapt the motion to any incompatible with initial plans. Without any sort of initial plans, when any obstacle has been avoided, this particular type of the reactive obstacle avoidance has been used. That is, the main advantage of the reactive obstacle avoidance is to compute the motion by introducing the sensors information within the control loop, where it is used to adapt the motion to any of the contingency incompatibility within the initial plans. Next, what is slow motion? Slow motion means what? Right? Generally, slow motion means when a robot is traveling from one point to the another point, where it is not having the initial speed or when it is very comfortable in moving with its idealized plan, that is known as a slow motion being taking place in the robot. This is one of the very simplest type of the motion. Right? The slow motion analysis in the robot is one of the very simplest type of the motion in the robot, where the robot is commanded to travel from one point to the another point at a default speed, that is a slow motion, right? Right, from one point to the other point, the robot is moving at a default speed, that is, it is not increasing its speed but is not reducing it is moving from one place to the other at a constant ratio, that is known as a slow motion, right? Whereas without any calculations, it often leads to unpractical results and wear on the robot joints, right? Performance without any of the calculations will lead to the unanticipated results and the wear on the robot joints. Okay. Next, what is joint interpolation motion? What do we mean by joint interpolation motion? Generally, this particular type of the motion is used to calculate the time it will take to it will take each joint to reach its destination at the commanded speed. Right? This joint interpolation motion is used to calculate the time at which the robot joint is reaching the destination point at a certain speed, right? Understood. Joint interpolation method is used to calculate the time of the joints, right? It is used to calculate the time of the joints where it will at what destination this particular joint is moving at what time at a certain speed is known as the joint interpolation motion. That is, the joint interpolation motion requires the robot controller to calculate the time it will take where each joint to reach its destination at the commanded speed is known as the joint interpolation motion. Yeah. Next, moving on to the next step. What is straight line interpolation? What do we mean by the term straight line interpolation? Generally, this particular straight line interpolation is being considered for x and y coordinates. Right? When we have x and y coordinates, this particular interpolation motion requires the end effectors to travel along a straight path. Right? This particular interpolation requires the robot's end effect. When the robot's end effector is moving in a particular straight path, which is determining the x and y coordinates, is known as the straight line interpolation. Clear? When any particular robot's end effector is moving in a straight path, which is following the x and y coordinates, is determined as the straight line interpolation. Next, circular interpolation means the robot's end effector when it is rotating, right? When it is rotating in the circular motion with a minimum 3 specific position. Obviously, when a robot is being rotating in, for example, this is the robot M effector and it is rotating in the circular direction. So it is coming across x-axis, it is coming across y-axis, it is coming across z-axis. That is, it is moving at an angle theta, or it is moving at an angle psi, or it is moving at an angle psi, pi or psi. It is the circular interpolation motion requires the robot controller to define the point of a circle in the workplace based on minimum 3 specific positions. This is when the robot's end effector is taking a rotary motion, that is in a circular direction, where it is defining the 3 positions. It is that particular concept is called as circular interpolation motion. Next, what is an actuator? Actuator is something where it is used to move the manipulator of the robot. Right? The actuator is a action plan which has been taken to move or to have a movement in the robot's manipulator. That is known as an actuator. So here in actuator we have 3 types of actuator. One is the pneumatic actuator, Here you can see hydraulic actuator, and the other one is the stepped motor type of the actuator. Generally, the pneumatic actuator is being used with the help of the air. Right, the actuator's working principle is being done with the help of the air. As the air is being sucked, it expands the piston movement within the cylinder of the robot's manipulator, and with the help of which the robot's manipulator movement is being taken place. That is known as the pneumatic actuator. Whereas in the hydraulic actuator, the working principle is based on the fluid, whether it is a fluid or an oil. As the oil or the fluid is being sucked inside the engine cylinder, the pressure whatever is being created within the engine cylinder pushes the piston in the forward direction, right, pushes the piston in the forward direction, due to which the robot's manipulator will start moving, right. That is known as the hydraulic actuator. That is, the hydraulic actuator, as I've told you, it is based on the fluid, where the power of the hydraulics is used to create the mechanical action. Right? The motion can be a straight, rotating, or a oscillatory motion. So here, this particular type, when we're using this particular type of the actuator, the motion of the manipulator can be in a straight line, rotary, or an oscillatory motion. Right? This an actuator is something which is used to have the movement in the robot's manipulator, where we have three types of actuators: pneumatic, hydraulic, and stepped motor. Where in pneumatic, as the air is being sucked inside, it creates some pressure inside the engine cylinder, or inside the particular cylinder head, and moves the piston in the forward direction, due to which the robot's manipulator movement is being taken place. Whereas in the hydraulic actuator, we will be using a fluid or an oil where it is sucked inside, creates a pressure, and moves the piston in the forward direction. And the same way in the stepped motor type, here we will be using a, that is a mechanical, or in a stepped motor type, we will be using a motor which is a direct current or a alternative current motor, due to which the robot's manipulator will be moving, right. Next, as we have already studied about the pneumatic actuator is nothing but it has been worked on the compressed air, which is used to make the energy into action. Right, the energy has been created into the action, as we have already discussed now. Next, moving on to the next one, mechanical actuator. Mechanical actuator means what? It has been working with the help of the pulley, gear, rails, chains. Right, that is where it is the rotary motion is being converted into the linear motion. That is pulley. Pulley means what? How is the pulley action being taking place? We will be having a wheel on which we have the thread being placed, and as this pulley is being rotating, the thread is moving, or the robot's manipulator will be moving. Or when you will take a gear mechanism, when we are taking a gear mechanism, as the gear is moving, the robot's manipulator starts moving, or the rail or the chain mechanism is the same. That is, the rotary motion is being transformed into the linear motion of the manipulator. Right, linear motion of the manipulator. That is known as the mechanical actuator. So these are the differences. So in today's concept of definition and terminology of trajectory planning, we have seen few very important terminologies and definitions, like what do we mean by trajectory planning, or what do we mean by geometric constraint, right? And what is the role of optimization, or what is joint space trajectory? What is the difference between the joint space trajectory and interpolator trajectory, or the role of obstacles avoidance, and what is the advantage of reactive obstacle avoidance? What do we mean by slow motion in the robot, and how it is being considered at what constant speed, and what is the use of the joint interpolation motion, and what is a straight line interpolation, what do we mean by circular interpolation, on what is an actuator, what are the various types of actuator, and how those particular actuators are being working, what are the basic principles of the actuator working, we have seen in today's concept. One more important topic I want to discuss here is about path planning. Right? What do we mean by path planning? Here, the path planning is nothing but the robot has to plan its path initially, rather than after starting the work. Right? If the planning is being done, the time consumption will be more. If the robot is planning its path before the start of the time consumption will be reduced, where and it can identify at what place the obstacle is, and the path planning will be done very smoothly. Right? The trajectory planning and path planning are very two important concepts in this particular module. Right? Hope you have understood about the definitions and terminologies of Module 4, that is the trajectory planning. In the next class, we will discuss about the definition and terminology of Module 5, that is various applications of robots. Right? Signing off for today, Dr. HIma Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.